All right, let's talk about the invisible engines that basically run our entire digital world. I mean, they're working silently, all the time, in the background, connecting every single app and service you use. We're talking about APIs. And today, we're going to pull back the curtain and see how they make everything, well, possible.
Just think about the last time you ordered food on an app. It shows you a map, right? It lets you pay with just one tap, and then it gives you real-time tracking of your order. So, how on earth does one single app do all of that? Well, the answer is this really elegant piece of tech called an API.
So what even is an API? Honestly, the best way to get it is with a super simple analogy. Just picture yourself in a restaurant. You're the customer, and you want food from the kitchen. The thing is, you can't just stroll into the kitchen yourself, right? You need someone in the middle.
Let's just break this down. You, the customer, are the user on an app. You decide what you want, you place your order. Now, the waiter. The waiter is the API. They take your very specific request, your order, and they communicate it to the kitchen in a language the kitchen understands. The kitchen, that's the server. It has all the ingredients, all the data, all the functionality. It prepares your order. And finally, the waiter brings that finished dish right back to you. That delivery, that's the API response. See, the API is just that critical messenger that makes the whole thing work.
And that brings us to the more, formal definition. An API, which stands for Application Programming Interface, is really just a communication bridge. It's a set of rules, a protocol, that lets totally different software applications talk to each other, share data, and ask for things from one another, all without needing to know the messy details of how the other system is actually built.
So, where did this amazing idea even come from? Well, to get that, we have to go back in time, back to when the digital world was a very, very different and much quieter place.
In the early days of computing, software programs were basically like little isolated islands. Each one did its own thing inside its own system. And trying to get them to share information or work together? Oh, it was a nightmare. So complex, so inefficient. That was the fundamental problem that needed solving. How do you get these separate digital islands to actually talk to each other?
And the solution? Well, it evolved over decades. Back in the 80s, you had basic APIs that just let software talk to the computer's operating system. Then the internet exploded in the 90s, and we got web protocols like SOAP. But the real game changer was in the 2000s with something called REST, which made web APIs way simpler and so much more powerful. That really paved the way for the modern era of microservices, leading to even faster, more flexible APIs like GraphQL, and now, of course, the incredibly powerful AI APIs that run tools like ChatGPT.
So, who do we thank for all this? Well, there's no single inventor you can point to. The modern API is really the result of a massive group effort. You've got brilliant thinkers like Roy Fielding, who designed the REST architecture that most of the web still runs on. You've got standards organizations like the IETF, and of course you've got trailblazing companies like Salesforce and Amazon who were some of the first to realize the immense business potential of opening up their platforms with APIs.
Okay, so we know what they are, why we have them, and where they came from. Now let's get into the good stuff, the different kinds of APIs out there. Because they're not all the same, not by a long shot. Different APIs are built to solve totally different problems. So let's take a little tour of the digital toolkit.
For a long time, the two main players on the web were SOAP and REST. SOAP is the older, more rigid one. Its strict rules make it super secure, which is great for things like banking. But REST became the king because it's just so much simpler and more flexible. The key thing about it is that it's stateless, which just means every single request is a fresh start, independent of any others. That simplicity made it absolutely perfect for the fast-paced world of web and mobile apps. And more recently, new kinds of APIs have popped up to solve new problems. GraphQL is amazing. It lets an app ask for exactly the data it needs and nothing more, all in one go. gRPC was built by Google for pure, raw speed. It's perfect for all the tiny internal microservices inside a big app that need to chat with each other instantly. And then you have webhooks, which are kind of cool because they work in reverse. Instead of you asking for data, they just push it to you automatically the second something happens.
But what's really fascinating is that APIs go way beyond just the web. I mean, look at this. At the most basic level, you have system APIs, which let an app talk directly to your computer's operating system, like Windows or Linux. Then you have library or SDK APIs. Think about the Google Maps toolkit. A developer doesn't build a map from scratch. They use the API to plug all that power right into their own app. Cloud APIs are absolutely massive today, giving us access to huge services like Amazon Web Services or AI models from OpenAI. And it even gets physical with hardware APIs, which let you write code to control actual real-world devices like a Raspberry Pi. How cool is that?
And one last thing on types. Not all APIs are open for everyone to use. A ton of them are private, used only by a company for its own internal systems to talk to each other. Some are partner APIs, which are shared securely with, specific business partners. And then you have the public APIs, like the ones from Twitter or Google Maps, that are open for any developer anywhere in the world to grab and build something new with.
So we've covered all the different flavors of APIs, but what does one of these interactions actually look like? Let's take a quick peek under the hood and see how it all works.
It really all boils down to a simple loop, the request-response cycle. It's like a conversation. First, a client, say your phone app, sends a request asking for some information. The API acts as the bouncer at the door. It receives the request and checks to make sure it's valid and has permission. If everything's good, it passes the request onto the server, which does the work, finds the data, and sends it right back.
And here's what that looks like in the real world. A request can be as simple as this: get/users/1. All that's saying is, hey, get me the information for the user with ID number 1. The API delivers that message, and the server sends back a response, usually in a clean, organized format called JSON. You can see it right there, neatly labeled data like name and the value, Akash. It's really that simple and that powerful.
Okay, so we've gone through the technical stuff, the history, the different types, but let's zoom out. What's the big picture here? Why does any of this actually matter to you?
Here's the most important takeaway. APIs are everywhere. They are the hidden backbone of your entire digital life. That map in your food app, that's the Google Maps API. Paying for something instantly with UPI, that's a whole web of banking APIs working together. Every time you see login with Google, you're using an API. And every single question you ask an AI model like ChatGPT is sent and returned through an API.
And this quote just says it all, doesn't it? Without APIs, all of our apps and websites would be stuck on their own, completely unable to work together or share anything useful. The internet would be a clunky, disconnected mess. But with APIs, we have this seamless, interconnected world where services can build on top of each other to create things we couldn't even have imagined years ago.
APIs have completely transformed the internet from just a collection of documents into a massive, programmable platform. They give anyone, from a solo developer in their bedroom to a giant corporation, the power to tap into these incredibly complex systems with just a few lines of code. So now that you can see these invisible engines that are running our world, the only real question left is, what will you build with them? Thanks for watching.